Hi everyone, we're going to graph quadratic equations of this form here. So we're dealing with the A part and the C part. This is the introduction to quadratics, and on these three graphs here I graphed the parent function. I'll talk more about that in the next slide. But basically what we're doing is graphing the quadratic function and doing transformations. The A part is what stretches it, so we're talking about number 1 here. Stretches or shrinks the graph. So if A is greater than 1, this part here, it's going to stretch it like a rubber band. Pulling on a rubber band, if you pull on it tightly, if A is big, that means you have a strength, and it's going to be more narrow. It's like pulling a rubber band up, and it's going to make it more narrow. Now, if A is less than 1, and basically, let's write this different. If A is less than 1 but bigger than 0, that means it's a fraction. That means you're weak. That means this is more of a shrink, and it lays flatter. And so it's going to be more wide, depending on what the number is. You just don't have the strength to pull this. So that would be if it's a fraction. Okay, and the vertex for here is 0, 0. A vertex is the point where it stops going down, and at that point where it starts going back up. All right, now when we talk about A is less than -1, that means it's negative, and all it does is it reflects it across the x-axis. Again, this is xy, xy, so it just reflects it here. And when I reflect it, it's going to look like this. Well, if I just reflect the regular one, it's just going to go down. So I'm going to go 0, 0, 1 goes to 1. Again, we'll talk about this in the next graph. And 2 goes to 4. 4. So it's going to be like that. It's not a very good graph, but this is just like a general concept. Okay, so if it's less than -1, it's going to be narrower. It's a stretch, but a stretch down. And if it's fractional but negative, then it's wider and it goes down. Again, we'll talk about these later. Now, the C part is the vertical shift up and down. So if C is bigger than 1, let's say it's 2, the whole thing just gets shifted up. It just gets shifted up. All right? And if it's less than 0, say -2, it gets shifted down. So you're just taking the graph and shifting it down. So those are the key concepts we're talking about. We're talking about vertical stretch and shrink, which is number 1. So this is called the stretch and shrink. And you probably should say vertical, stretch and shrink. This one is the reflection, number 2. And number 3, the C part, is the vertical shift up and down. So up and down. Okay, let's do some examples because this is just the concept part. So I went ahead and took the liberty of drawing the parent function. I'm going to go ahead and do a table of values. So for my parent function, y equals x squared, means it's very plain. I'm going to input values -2, -1, 0, 1, 2. Now if I square this out, I'm going to get 4, 1, 0, 1, 4. And that's where I graphed it here. I also graphed it, I did 3. And -3 would go to 9 as well. And it's symmetric. This is symmetric. It has an axis of symmetry here at x equals 0. That means I can fold it on this x equals 0 line, and it should match up. So the distance here, which it doesn't show very good here, I need to erase this. Go to 3 here. So this distance here is 3, and this distance here is 3. Okay? The distance between these two are 1. The distance from these two are 2. And actually the 3 should have gone up here. So the 3 is right in here. Distance here is 3, 3, 2, 2. Okay, so we have this. And now what I want to do is this transformation of changing the 2. So basically what I'm doing is I'm stretching this. And when I stretch it, I'm basically multiplying my y by 2. So if I take my y and multiply all this by 2, I'm getting 8, 2, 0, 2, 8. And I'm going to go ahead and erase this back out and draw this. So basically, I'm still starting at 0 because 0 times 0 is 0. But when I go to 1, 1's going to go to 2. So 1 goes to 2 here. Also on this side, negative 1 and 1 go to 2. 2 goes to 8, and here's 8. So 2 goes to 8. Please draw. All right, 2 to 8. And then I connect it, and you can see it's a stretch. It gets narrower and gets closer to the y. Okay? All right, and the vertex here is 0, 0. So we would call this a vertical stretch by 2. Okay, the next one we have is a stretch, but it's a reflection. So basically, I'm going to reflect it, but then I'm from 1, 1's going to go to negative 2. Negative 1's going to go to negative 2, and 1's going to go to negative 2. 2's going to go to 8. So it's just like the other one, but we reflect it down. So this goes shifted down. This gets stretched like this. So it's narrow in its reflection. So we had a reflection and a stretch by 2. Okay, so we had 2 things going on here. All right, the next one, I have the shift up by 2. So basically, I'm starting at 2. I'm starting at 2 here, because when x is 0, you plug in 0, we're up at 2. And then from here, what I do is I just draw my parent function. So from here, I go up to here, and 2 is going to go up to 4. So from 2 and negative 2, I'm going to go up to 4. 1, 2, well, from here. 1, 2, 3, 4. And then it's symmetric. So I'm just going to go over here, and this got shifted up by 2. All right, same shape, but the whole thing got shifted up by 2. You can always do a table of values or use your calculator depending on what your teacher lets you do. All right, so this is called a vertical shift up by 2 units. All right, here's my parent function. I already kind of plotted the points and made it symmetric to the x-axis. All right, and this is going to be a vertical shift down by 2. So I go down 2, and from here I'm just going to graph it normally. And then from 2, I'm going to go up 1, 2, 3, 4 here. And go from 2 to 4, so I'm just going to get shifted down by 4. Not a very good drawing, Well, it got shifted down by 2. So vertical shift down by 4 units. All right. Compared to the parent function. All right, let's do another one. Let's do the shrink. So let's do y equals 1/2 x squared. Now, I'm going to graph my parent function. So 0, 0, 1, 1. Negative 1 goes to 1. 2 goes to 4. 1, 2, 3, 4. And so basically what I do is I just make it symmetric. It's 2 here, so I'm going to go over 2 here. 3 goes to 9. So put that here and this here. And I sketch it. I just make it symmetric to the x-axis. And now I have to graph this one. So we'll do this one in purple. So that means we have very little strength. So 0 is still going to be at 0. But when we plug in 1, that's going to go to 1/2. And 2 is going to go to 1. And basically, from there, I'm not going to do 3 because I don't want to graph that. I'm going to go to 4. 4 is going to go to 2. And I kind of just go from there. And you can see that it's a shrink. It's falling down. It's weaker. And so basically what I did is for this right here, I did a table of values. And what I did is I plugged in 0, and I got 0. Plugged in 1 and got 1/2. Plugged in 2 and got 1. I don't want to do 3, I want to do 4. 4 is going to, half of 4 is 2. And probably the next one I want to do is 6, because half of 6 is 3. I want to do easy things because I'm just trying to get the graph here. And then all I'm going to do is make it symmetric on the other side. Since this went over 4 here, I'm going to go over 4 here on this side as well. So that's how I would graph that. Now if you want to do negative, let me see if I can squeeze a negative in here. You're going to graph this same thing, but all of these signs, the y is going to be negative. So it's just making your y negative. So I'm just going to make all this negative. My x is the same, and I'm just flipping this over. So I'll do this in, well, I can do it in red. So I'm just going to go down here, here. This went to 1. 2 goes to 1. 4 goes to negative 2. 3 would go to what? 6 goes to what? So we go, this is 4, 5, 6. 6, let's see. 1, 2, 3, 4, 5, 6. 6 goes to 3. So there it is. That would just be a reflection and a shrink. So this purple one is a shrink, actually a vertical shrink. I don't know how to spell, so I'll try again. Vertical shrink by 1/2. This is the same thing, but we also did a reflection. So this had two things, the reflection and the vertical shrink. Okay. The next video is going to be about graphing using y equals ax squared plus bx plus c. That means we're going to graph quadratics in standard form. Have a nice day.